Hi everyone, welcome. Today we're going to learn about how we can extract time series data, in this case soil moisture data, using the SMAP sensor. A SMAP is a global a sensor that captures global soil moisture data. And when you're done with this analysis, we'll have something like this, a time series soil moisture data, satellite-based soil moisture data, which has a year, months, and also the soil moisture statistics based on a zonal statistics analysis. So when you're done with this analysis, you'll have something like this. Let's get started. So we'll be using Google Earth Engine. So if you're new to Google Earth Engine, you can type in Google Earth Engine, and this is Google Earth Engine. So if you're new to Google Earth Engine, this is a cloud computing API. They have a commercial and a free for educational and research purpose. So you can apply for an account for a free use for educational research purpose by clicking here, Get Started. So if you already have an account, you can get started. So we'll be using going to datasets and type in SMAP here. So if you type in SMAP, you find the soil moisture data, which is a global data here provided by NASA. And so we'll be extracting a time series, monthly time series based on this sensor. So once you are to the Earth Engine platform, what you can do is just click platform and code editor. So it will take you to the code editor API, and you'll start just coding there. Okay, so this is a code editor. You can do if you're new to Earth Engine, this is your first time. So click. You can execute Hello World, the standard first test programming language, and then you can execute that here. This is the JavaScript API programming application interface. So you can see the Hello World here printing. So the JavaScript API is working in my case here. You can test it on your end just to make sure that it's working. So once you're done with that, let's get started to coding. So the first thing is, so I always like to load my study area, region of interest, to subset my data here. So I will provide a creative variable. So in JavaScript, you have to start with var when you declare a variable, and then countries. So EE feature collection. So if you're interested about how you can get the countries database, you can go to Earth Engine and datasets here, and then just type in LSIB. So it will give you that the 27 countries, world countries boundary. So that's what I'm technically copy pasting here. So you can copy that. Just that's actually opening that. So copy here, and let me just get rid of this to avoid confusion here. I don't want to have multiple windows. So we can have, so we imported countries database from Earth Engine. So this is just all countries. So instead of using all countries, I'll just choose one country, so that I'll have a smaller subset, right? And then import, let me just clear this, and import this, and I'll subset from countries database using Earth Engine filter algorithm, EE. So filter equal, and then I'll provide the specific filter parameter, in this case country NA. That means country name. So in this database you have a country NA field which denotes country name. So you can specifically choose a country. In this case I'll choose Ethiopia. You can choose a different country if you want to. So now I've created my region of interest, right? So the next thing is, because this is a long time series data, I'll be providing the list of years and a month's sequence here, 1 to 12. Let's create a years variable. List sequence. And SMAP actually has been launched in 2015. So let's start from 2016. And we'll need data until 2021. Okay. And close the bracket using a semicolon. That's how you close a statement in JavaScript. And let's also create months list. That's we can copy actually the sequence here. That function, that Earth Engine built-in function, and then let's just do this list capital. And then for months, we have a sequence 1 to 12, right? All right, let's just load the SMAP data collection here. And then image collection, that's how you call a image Earth Engine image collection. And then actually you can go to the Earth Engine side and then data SMAP here to just copy the image collection ID. So we can copy that image collection ID here, and then we can paste that. And there are multiple variables in this image collection, so we want to select SSM, soil moisture, and let's print actually the collection, right? Collection. And then this is a large volume of data, so we just want to print only the first image. So that way we're not gonna max our Earth Engine quota. So let's just execute that. Some error here. Months equal, that's why. Okay, so let's just execute that. So excellent. So we have, let's just actually enlarge so that we can look at the code clearly. So we can look at that. So what we printed is just, we printed this image collection to see, what the different metadata information or image property, in the image collection. But because it's a large data, we just only printed the first by doing collection dot first, right? And let's look at this. So the properties, so you have system, time start, and whatnot. And in terms of the band, you have the SSM, right? So we didn't do anything. This is just a raw image collection, okay? So next, let's create a variable. This one is export. Okay, so let's just push this down a little bit. So we have now the image collection. The next thing we need to do is actually create a visualization parameter, right? So that we can display the data before we do anything. So let's create a variable, soil viz is equal to, we'll open a curly bracket here, and we just define the minimum value and then the max value. That means the minimum and the maximum values in this soil moisture data. And then we can create a palette for the colors, right, to store the color information. When we visualize, this is how we want the different colors. You can go to Color or other just color platforms to pick these different colors. This is optional, you can change it if you want to, but for now I'll create this color ramps for me, and some 4 or 5 different colors, right? and then a single quotation, and then I already know this beforehand, so don't worry about this. And EF, these are just different colors for my legend later, or the map display. And then next one is, let's just create a single quotation. Actually 0303. Okay, I think this should be fine. And then since we have I think this should be fine, and then let's close that. Okay, perfect. So this is our visualization. Let's just close that statement, and then the next one is just the map center. Usually just to, when you open the map canvas here, you can just toggle satellite and map, Google Maps. So this is a global data, like the global view for all continents. So just you want to have a specific location so that you can see that specific location when you execute the code, right? So that's what we're doing here, like map set center. That way when you execute the code, we'll just zoom into that location. So the first and the second one are like longitude and latitude, and this is a zoom level. Usually our engine has a zoom level between 1 and 16. And the last thing is just actually create a map add layer, that function, to add our soil moisture data, which is a collection, but I'll do mean because okay. And then the other thing is I'll add my visualization here just so that I have some color coding here. And oh no, sorry, that's just I put here, it should be outside that bracket. And then finally I'll create I'll just give it a name like soil moisture. This is just a layer name. When you execute it, it will show up over here at the bottom in the map canvas. So I'll execute this. What I'll see is just a soil moisture and color ramp, if it does work correctly. And what's going on here? So the coloring doesn't work nicely. So, oh, okay, so this is why. All right, let's just execute again because it didn't read the color codes properly earlier. Here you go. Yeah, so just some typo here. So now this is global soil moisture data, right? So you can visualize that, so high soil moisture, so you can see here areas where you have, higher soil moisture, including yellow and red, and blue is areas where you don't have soil moisture is pretty low or dry. You can see the Sahara Desert and whatnot, like East Africa, coast, pretty dry areas here. So yeah, so next step is just once we visualize this, the next step is actually to summarize our data so that we have a table, right? So we want to summarize our data by months and year. So let's just I've already written the function that does this. So the first thing is just let's create the different year, like the timestamps, right? So we have our collection. Let's just toggle this down. So we have our collection here, right? So we're gonna call that and select that, and then we're gonna generate some timestamp here. So that's what we're doing here. Just all right. So date, months and years. So we're defining the timestamp here, and then we can. So we call it like SMAP. So this has instead of the raw image collection, this one has a more calendar time, day, months and year. if you look at the raw image, it has you know, system time start and system time in, which is difficult to read this for a human. It's computer readable, but so what we're doing here is just to convert that to a human readable timestamp, right? So let's just look at this second one here. Okay, so now you can see you have year, right? And then you have months. So that's what we're doing here. When you look at the raw data, you don't see that. So that's what this function is doing, okay? So the next function is actually our main function. What it is doing is technically generating monthly data for each year, okay? So first thing what we're doing is this image collection from image and then years. So what years is the list of years that we've defined earlier, okay? So this is what we're providing. So what we're generating here is just, instead of the raw image here, we want to catalog it into every year has a month from 1 to 12. So now we have this function that's generate a monthly data. How is it doing? So first you call the years and you call the months, and then you map it to every image. And what you do is you return SMAP, which is this image collection was calendar time, months and year, right? And then you filter year equal to specific year, and then also filter months equal to M. And then you also select the specific parameter, which is soil moisture. And then for each month and year, you generate the mean of all images existing in that month and year. So in effect, what this gives you is just, it will give you a monthly mean. All right. So a monthly mean, if you have, like, for example, if you have 7 images in a single month, it will calculate the mean of those 7 images in that specific month. Okay. So now you have a function that does calculate monthly soil moisture data. Let's just print this to make sure that we are having this correctly. So let's type by year months. This is just for us to remember, comma, and then call the actual function that does that, right? Like, let's print that. We'll know what's going on with that once we do that. Okay. And then because this is a large data set, we want to print only the first one. Okay. Let's execute that. Let's just execute this and see. So by year months, right? By, it's computing. So it's computing on the Earth Engine cloud on the other side. And let's wait until this is done. Okay, it's done. So excellent. So what we have now is instead of multi image, we have one single data set, all right, for each month. For example, this is month 1 and year 2016. Excellent. So that function is working, and the other thing is actually to do zonal statistics, right? We want to generate a zonal summary to generate a table. So this is the image, right? You want to do a zonal stats. So this is zonal statistics. Zonal statistics. What we're doing here is just calling this image collection, right? And then we have a region of interest. You remember? So here's the region of interest. We selected the specific region of interest, in this case a country, Ethiopia. All right, so we want to summarize, we want to generate a zonal statistics for that specific region here, in this case Ethiopia. And and also just return like months, year, so that we have those timestamps in our table. Okay, and okay, so we just defined projection information. So we extract the projection information and just apply it here. You know, sometimes if there's projection misalignment, there will be some error, just to avoid that. So that's the main function here. Look at this. So we're using reduce regions. That's the zonal statistics analysis here going on. Okay. So our feature is here is just a region of interest, and then we apply EE reducer mean, Erzincan reducer mean. So that's a zonal statistics. Now we're calculating the mean. All right, the mean within that specific spatial domain, or just a polygon or a region, right? And then we can define a spatial scale. In this case, we define 1000. You can change this scale if you want to. So when you execute this, it will calculate technically a zonal statistics, all right, for each month and year. Okay, excellent. Let's actually print that. So SMAP summary mean, SMAP, let's just limit by 10 because that's a large volume of data. Before we export it to our Google Drive, let's just look at the data itself, right? So what we'll see here is just hopefully when this is done, a zonal stats summary, for each month and year instead of an image collection. That's what we're seeing here. So technically a table. So let's print that, execute this and print the table that's already the result of a zonal stats summary using a mean for each month and year, and computing here on the cloud. Let's just wait a little bit, and once this is done, we can see at least print the first 10 summary table. So you can see here about 10 data points. Let's just look at that one example. Okay, so this is how the exported data set is. Just you have year, months, and also the mean value, soil moisture value. Excellent. So the last thing is just to export actually this data. So you can export this using this function. So you have export table to drive function, which has a collection, a description of the the exported file, and file name, prefix, and whatnot. And the most important thing is just you need to define a file format, which is a CSV. And selector is usually just to define the different attributes or fields that the exported table has. And just finally, let's execute that. Let's just change this to SMAP Ethiopia. That's exactly matching this zonal stat summary. What else? Let's just update this. SMAP. Excellent. All right, so let's just go ahead and execute that. Now, once you're done with that, you have tasks that need to be exported. So just what you do is you go to that specific task, which is SMAP Timeseries right here, and then click run, and then that will export the CSV table to this folder in your Google Drive. So check Erzincan data folder in your Google Drive, which is here. So let's see if that's already downloaded. Actually, you have to wait until this is done. Okay, so this is busy, so you have to wait a little bit. Once that's done, you'll have your table, and we'll download that and just open it as a CSV table. And Excel, just you can do graph and plots and whatnot. So let's just wait a little bit. Okay, excellent. This is already done. So let's just open that. It shows you a check mark here. That means the download is done. Here you go. So you can see that we have our table, we have our months and year, and country NA, which is Ethiopia, and then this is the mean soil moisture for all months. So you can download that and you can open that. So this is technically so in your Google Drive you can just click that, and here's the data, months, year, and mean. You can download that and just open that. So this is exactly as I've shown you earlier. You can plot it in a graph. So you have year, months, and mean soil moisture. So you can do anything with this one. Like you can generate a report, or use it for publication or analysis, scientific analysis, and whatnot. So that's how you can export time series data using Earth Engine, and SMAP data.